Okay, well, so now we're going to look at an example of ANOVA. So this is one of the ones from the lecture. And here we're looking at if the level of facial symmetry affects how attractive we think people are. Okay, so we have three levels of symmetry. One, okay, if you look at the code over to this side right here, 1 equals highly asymmetrical. 2 equals slightly asymmetrical. And 3 equals symmetrical, and you can see that in this level of symmetry over here, there they are, okay? And we also have how the individuals have been rated on attractiveness. So they go from 1 being that's a very, very unattractive person to 7 being, that person's a god, they're an Adonis, they're beautiful, okay? So you may be wondering, well, why can't we just do a t-test? Well, the issue is we have more than 2 groups, and that's when you would use a t-test for independent samples. So we have 3 groups, so we're going to use an ANOVA. So instead of parametric tests, which is what we used last time, we're going to go to modeling data, actually, and we're going to choose the ANOVA. Okay, so here we're going to pick the quantitative variable for our dependent variable, okay, and that's going to be level of attractiveness is our dependent variable. And then we have a qualitative independent variable, which is level of symmetry. Okay, and I'm just going to select all of that. Okay, all we need here is just a tolerance, validation, don't worry about it, prediction, we don't want that. We don't have missing data. Now for outputs, we definitely want descriptive statistics. We want the analysis of variance. And you can do the pairwise comparison, and usually one will do the Tukey. So if you remember from looking at the lecture notes, in an analysis of variance, to see if there are significant differences between the subgroups, you actually have to run the follow-up pairwise comparisons or t-test. So that's what we're doing here. So we're going to click OK. We'll get this message again, and then we're going to click OK. That's fine. Okay, so here we have our results. And okay, we have 18 observations, which should be right. Okay, minimum of 1, maximum of 7. We have a mean standard deviation. Okay, so we have these goodness of fit statistics. Okay, then we get our analysis of variance. This is our F table. Okay, so this is the same as between groups. This is the same as within. Okay, and then we have the sums of squares. Okay, now if you looked back at my lecture notes, you saw all this. There were all these crazy calculations, and that was getting us to our sums of square measures. Okay. Okay, and then to get our mean sums of squares, we divide our sums of squares by our degrees of freedom. Okay, so it gives us our mean sums of squares. And then to get the F, we divide the model, or with it between group sums of squares, divided by the error. Okay, and then this gives us our probability, which is less than 0.01. So that tells us it is significance because it's less than 0.05. Okay, and so if you wanted to look at then the follow-up, so to see where the significant differences are, we can look at this, the differences between the categories. Okay, so this is comparing category 3 to category 1, category 3 to category 2, and category 2 to category 1. And we can see that in fact all the differences between the groups are significant. Okay, so that's an ANOVA in Excel. It's pretty simple. It's giving you the same F table you would get if you eventually did it by hand. And it does the nice follow-up t-test for us all in one step, so we don't have to follow through with that. Okay, that's it, and I'll see you later.